Hi everyone, Miss Wells here, and we are back at it with our periodic table today. So as you see, I have a fresh periodic table in front of you, and I went ahead and I labeled my periods 1 through 7 and my groups 1 through 18. Remember in one of the videos previously, I mentioned that these transition metals don't like to follow the rules. So again, I'm going to go ahead and lump these together, our transition metals, group 3 through 12, they don't like to follow the rules. The rules that I'm talking about are being introduced to you today. So what I'm going to do first is relabel some of my groups. Remember, my groups are my columns. They're also called families. So I'm going to relabel group 1. I'm going to call it 1A, 2A. Skipping my transition metals because they don't follow the rules, so we're skipping over them. So group 13, I'm also going to call that 3A, 4A, you see where I'm going with this, 5A, 6A, 7A, and finally 8A. Okay, we're going to pause on this for just a minute, and I'm going to take you to another worksheet where we're going to talk a little bit more about electrons. Today is all about electrons. So this worksheet will look a bit familiar to you. We used it in our last unit, but we're going to take it a step further with this unit. So again, we're talking all about electrons today. So we know that electrons are situated outside the nucleus, right? And we also know that electrons are moving really, really quickly and that we can't exactly pinpoint where they are at any given point in time. But for the purposes of us understanding how atoms interact with each other, we use a model called the Bohr model. B-O-H-R, the Bohr model. It's much like the solar system model that we talked about last week with atoms. So you have the central part of the atom where the nucleus is, and then we have the electrons in these shells or these orbitals that are moving around the nucleus. So let's go ahead and get started and learn how we're going to draw these Bohr models for each one of our different elements. We're going to start with carbon. So here's all the information that we need to know about carbon to help us draw our Bohr model. So we're going to first start with the symbol, which is C. So we're going to put a letter C. That's going to be our central part of our Bohr model. So we automatically know what element that model is for. We also know that the atomic number for carbon is 6. We know that the atomic number tells us the number of protons. We also know that atoms are neutral. So if there are 6 protons, there have to be 6 electrons in one atom of carbon. Again, we're talking all about electrons today. So we're going to focus on these 6 electrons. We know the central part of our Bohr model is our symbol C for carbon. Now we're going to learn where we're going to put these 6 electrons in our model. Over here, I have a basic setup of how our Bohr model works. So this X is representing any element on the periodic table. It could represent carbon. Then we have orbitals that are surrounding that central part. Our first 3 orbitals, which are the only 3 orbitals that we will work with in 8th grade science, are the K, L, and M orbitals. Over here on the side, I identify how many electrons can fit in each one of those orbitals. The K orbital can hold 2 electrons, the L orbital can hold 8 electrons, and the M orbital can also hold up to 8 electrons. Now, this information is true for elements 1 through 20, which those are the only elements that we're really going to be focusing on for the rest of this quarter and into next quarter. So these rules are going to apply to the elements that we're talking about. So our K holds 2 electrons, our L orbital holds 8 electrons, our M orbital can hold up to 8 electrons as well. So let's go ahead and finish up our Bohr model for carbon. We know that carbon has 6 electrons. So in our very first orbital, which by the way, these are called either orbitals or shells or electron shells. So in our very first one, this is called our K shell, it can hold 2 electrons. I'm going to go ahead and place my 2 electrons there. What I like to do over on the side is make sure that I account for all of my electrons. So I know that I just put 2 in an orbital, so I have 4 left over that need a home. So I do have to create a second orbital. I'm going to create that L orbital. And the L orbital can hold up to 8 electrons. So I know that the rest of my electrons that I have left for carbon will all fit. And I'm going to space them out evenly to make my diagram look nice. And there you have the Bohr diagram for an atom of carbon. Let's move down to one of our other examples. Before we do another example, I want to talk about this vocabulary word, valence electrons. Valence electrons refer to the electrons in the outermost shell. For carbon, this shell with 4 electrons would be the outermost shell. So the valence electrons would be the 4 located farthest away from the nucleus in that very last orbital. Let's look at sodium. So sodium has 11 protons, which means it also has 11 neutrons. So let's start our Bohr diagram. Starting with the symbol in the middle, Na, I know that it has 11 electrons that have to be placed in orbitals. My first orbital can hold 2 electrons total. So I'm going to come up and subtract 2, and I have 9 left over. My second orbital can hold up to 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. I just put 8 more electrons in a home, and I have 1 left over. So I have to create a third orbital with 1 electron. Now all of my electrons for sodium are in those orbitals. Remember our valence electrons. They're the ones in the outermost shell. Sodium would have 1 valence electron. Let's look at aluminum. Again, starting with the symbol in the middle, I know that aluminum has 11 electrons. Oh, I'm sorry, not 11. Whoops. 13 electrons, because its atomic number is 13. So I'm going to write my 13 over here in the corner. My first shell can hold 2 electrons. 1, 2. So I have 11 more electrons to account for. Drawing my second orbital, I can fit 8 in my second orbital, which means I have 3 left that are going to go on my third orbital. So for aluminum, how many valence electrons does an atom of aluminum have? If you said 3, you got that right. So we're looking at the outermost shell for valence electrons, and aluminum has 1, 2, 3. Now, moving back over to where we first started, our periodic table. Remembering that I relabeled my other groups over here, 3A, 4A, 5A. So I'm going to show you a really neat trick to know how many orbitals each element needs to hold its electrons and how many valence electrons that it has just by looking at your periodic table. So we're going to look at carbon, and we're going to find carbon on the periodic table. It's right here. So looking back at our Bohr model, we said that carbon has 1, 2, 3, 4 valence electrons. And it is in group 4A. Every atom in group 4A will have 4 valence electrons. Let's also look at how many orbitals our Bohr model for carbon has. It has 1, 2 orbitals. Carbon is in period 2. So we know just by looking at our periodic table that an atom of carbon will have 4 valence electrons because it's in group 4A, and it will have 2 orbitals because it is in period 2. We also did the Bohr model for sodium. So we're going to find sodium on our periodic table. Sodium is right here. Looking back at our Bohr model, how many valence electrons did sodium have? In its outermost shell, it had 1. Look at what group it's in, 1A. Every element in group 1A will have 1 valence electron. Let's look at how many orbitals it has. 1, 2, 3. It's in period 3. Every element in period 3 will have to have 3 orbitals to hold its electrons. Let's look at aluminum. It's located right here. So looking back at our Bohr model, let's look at how many valence electrons aluminum has. 1, 2, 3. If it has 3 valence electrons, that must mean it's in group 3A, and it is. It also has 1, 2, 3 orbitals, which means that it has to be in period 3. 1, 2, 3, moving across, and it is. So our periods tell us how many orbitals that are going to be in our Bohr model, and our groups tell us our valence electrons. So let's take chlorine, for example. Chlorine would have 7 valence electrons, and it would have 3 orbitals. It had 7 valence electrons because it's in group 7A. It would have 3 orbitals because it is in group 3. So if I were to make my Bohr model for chlorine, so I'm going to do that down below here. So chlorine's number is 17, which means that it has 17 protons and 17 electrons. My periodic table tells me that it should have 7 valence electrons, and it's in period 3, so it should have 3 orbitals. So let's see if that's true. In my first orbital, I have 2 electrons. I'm going to do my subtraction up here. 17, I just put 2 in. That leaves me with 15. My second orbital, I can fit 8. That leaves me with 7 electrons left, so I'm creating a third orbital. Now let's check. Our valence electrons, 1, 2, 3, 4, 5, 6, 7. Perfect. Chlorine is in group 7A, telling us it has 7 valence electrons. Our orbitals, 1, 2, 3. Chlorine is in period 3, telling me that it has 3 orbitals in its Bohr model. The periodic table is awesome in this way. It's very organized, it's set up wonderfully, and we can tell a lot of information just by looking at it and by labeling our periods and groups. So again, to recap, our periods tell us how many orbitals will be in the Bohr model. Our groups tell us the number of valence electrons in our Bohr model. Message me if you have any questions, and I hope that you all are having a wonderful day.